Theorem of perpendicular axis. According to this theorem, the moment of inertia of a body about an axis perpendicular to the plane of the body is the sum of the moment of inertia of the body about any two mutually perpendicular axes both lie in the same plane. If we take a body which is lie in xy plane, then this z-axis, it is perpendicular to the plane of this body. If we want to find the moment of inertia of this body along this perpendicular axis z-axis, then the moment of inertia along this z-axis is equal to the sum of the moment of inertia of the body lies along x-axis and y-axis. This is the theorem of perpendicular axis. Let Iz be the moment of inertia about OZ axis and Ix be the moment of inertia of the body along OX axis and Iy be the moment of inertia of the body along OY axis. Then according to theorem of perpendicular axis, the moment of inertia of body along z axis is equal to sum of moment of inertia of the body along x axis and y axis. That is Iz is equal to Ix plus Iy. Now we are going to derive the proof for this. Consider a particle of mass m of a body at point P, which is at a distance r from the origin. Let pxy be the coordinate of this particle about z-axis. Then the moment of inertia of the particle about z-axis equal to mr square. We know that moment of inertia of a body is equal to the product of mass and square of the distance from the axis. So here moment of inertia along z-axis is equal to mr square, because the distance of this particle from this z-axis is r and mass of the particle is m, so it becomes mr square. Now the moment of inertia of the whole body about z-axis is given by Iz is equal to summation mr square. What you can see here, if you take this right angle triangle, suppose this is point A, O, A, P. So here this is 90. So OP ka square equal to OA square plus PA square by using Pythagoras theorem. OP ka square is equal to OA square plus AP square. OP is R square. This is equal to OA is Y square and AP is X square. So use this value of R square here. We get Iz equal to summation M X square plus Y square, and this is equal to summation mx square plus summation my square. When we distribute a summation m inside, this becomes summation mx square plus summation my square. Here the moment of inertia along x-axis is the distance of point P from this x-axis is y, and mass of the particle at point P is m. So moment of inertia along x-axis is summation my square, and the moment of inertia of the body along OY, that is y-axis, and the distance of this axis from this point is x. So moment of inertia is summation m x square along y-axis. What summation mx square, and it is equal to Iy, and summation my square equal to Ix. So this equation becomes Iz is equal to summation mx square, that is Iy, plus summation my square, that is Ix. So this implies Iz is equal to Ix plus Iy. This is the proof for theorem of perpendicular axis.